In this example, we'll be given the actual sample data in order to construct a confidence interval estimate of the mean, and we will not have the population standard deviation. Heights of adult females are normally distributed. Given the simple random sample of female heights below, construct a 95% confidence interval estimate of the population mean height of adult females. Okay, here is the sample data. They're not giving us the mean or anything about standard deviation. No statistics are given. They're just giving us the sample data. So we will look at both methods as we did in the last example. First, we will calculate the margin of error and then construct the confidence interval estimate. And the second one, we'll use our calculator. However, for either one of those, we do need the sample mean and the sample standard deviation. So clearly this is not a problem where we can be using the z-distribution, because nowhere in here were we given any information about the population standard deviation. So let's note some of the things we found, and then we'll calculate our some sample standard deviation and mean. Okay, so n, what is our sample size? Well, we have 4 rows of 3 heights here, so we have a sample size of 12. And we're going to calculate our x bar and our sample standard deviation. We'll need to get those. Sigma is unknown. It's a 95% confidence level. That means alpha is 0.05. That means alpha over 2 is 0.025. Okay, so we'll use our calculator to get the mean and standard deviation here. Alright, so recall that we go to Stat and Edit, and then we want the first function here, which is also Edit, and we're going to put our data in a list. 67.9, enter. 66.8, whoops. 66.8, enter. 64.3, 68.0, and it won't put the 0, that's okay. 59.6, 64.3, 66.4, 63.4, 60.5, 57, 64.8, and 59.6. And notice that's my 12th value. Now it's looking for the 13th, but I don't have that, so I know I've entered all my values. Now these it didn't state, but these are inches. Okay, so recall how we get the statistics for this. We go to now Stat Calc, and we want one variable statistics, the first function that's highlighted there, enter. And my list is list 1. If I didn't, if it wasn't indicated the proper list, I would say second and come down here and choose the correct list. And I don't have a frequency list, so I just go down to calculate. And now we get our sample mean, 63.55, and it terminates there at 2 decimal places. And our sample standard deviation, S sub x, 3.6122. So we'll be doing some rounding, so I'll carry that out, 3.6122. Okay? So we found for our sample mean, 63.55. Sample standard deviation, 3.6122. Alright, so now we're ready to start method 1. Where we use the margin of error calculation and our critical value. sample standard deviation over the square root of n. Okay, so the critical value, t alpha over 2, is t 0.025, 0.025, and our degrees of freedom, we didn't calculate that up here, degrees of freedom, n minus 1, will be 12 minus 1, or 11. Okay, and we'll get this by going to our distributions, inverse t, area 1 minus 0.025, degrees of freedom, we just said that was 11. Okay, that looks right. 2.20. Alright, so we have 2.20. Our standard deviation for the sample was 3.6122 over the square root of 12. And we get 2.294. Okay, so now that we have E, we can construct our confidence interval estimate, x bar minus E, x bar plus E. Okay, and x bar was, what, 63.55 minus 2.294 and 63.55 plus 2.294. Now remember the round-off rule. It says that if you do have the actual data, you want to round to one more decimal place than the actual data. So that means we'll be rounding to 2 decimal places. Okay, so 63.55 minus 2.294, we get 61.256. 63.55 plus 2.294, and that's 65.844. Okay, to 2 decimal places, and now with our units, alright, so we've constructed a confidence interval estimate for the mean height of females from 61.26 inches to 65.84 inches. That was method number 1. Okay, method 2. So we use our technology, stat, tests, and then t interval. Okay. Stat, tests, t interval. Now this time we do have the data. So we'll come over here and indicate that we have the data. Now I know we've calculated the mean and the standard deviation, but now we can just put in that we have the data. And let me go back and indicate that. Enter on data. See, now it asks me where the data is and what list. It is in list 1. If it wasn't the right list, I would just enter that. Second, out 1. My frequencies are 1. I'm not using a column of frequencies. My C level, confidence level, is 0.95, and then we calculate. Okay, 61.255, 65.845. Okay, and you can see that we get 61 rounded to 2 decimal places because we had that the actual data. And the only difference we see here, there's a slight difference in the rounding. It's way out at the hundredths place here, 0.01 inches, so that's close enough. That's pretty good. It just has to do with the rounding here and how much accuracy the two different calculations had. Okay, so we got the same result. Doesn't matter which way we do it, we still need our interpretation. We are 95% confident that the true population mean height HEIGHT of females is between, and don't forget the units here, 612.26 inches, and I'll just use the second one here, 68.85 inches.